All right, let's jump right into this explainer. We're meeting the new heavy hitter in the HVAC world today, R-32 refrigerant. As the global phase-out of R-410A accelerates due to changing environmental regulations, the whole industry is shifting gears rapidly. Today, we're going to break down exactly what R-32 is, why it's taking over, and everything you absolutely need to know to work with it safely in the field. Here is our roadmap for today. First, we'll meet R-32 refrigerant, then explore its eco and efficiency edge, move on to understanding A2L mild flammability, and wrap up with handling and installation protocols. So what's replacing R410A? It's literally the million-dollar question in the industry right now, right? With new global standards like the Kigali Amendment pushing us away from legacy refrigerants, technicians and facility managers everywhere are looking for the next standard. And the answer is a chemical that's about to make your installations and servicing a whole lot more efficient. Let's start with Section 1, Meet R32 Refrigerant. We're going to look at the actual resume of this next-generation cooling technology. Right out of the gate, let's look at its chemical identity. R32, or difluoromethane, that's CH2F2 for the chemistry buffs out there, is a pure single-component azeotropic hydrofluorocarbon refrigerant. It is not a mixture. Fun fact, actually, R32 already makes up half of the older R410A blend. But by using it completely on its own, we unlock some absolutely incredible properties. Being a pure single-component fluid matters immensely in the real world. Think of older zeotropic blends, kind of like a mixed cocktail. Over time, or during a leak, the components evaporate at different rates. That creates fractionation and temperature glide, which kills your heat transfer efficiency. But pure R32? It's like a pure spirit. Zero temperature glide. If it leaks, whatever is left inside remains exactly the same, with a perfectly stable composition. Moving on to Section 2, the Eco and Efficiency Edge. It turns out R32's unique chemistry translates into some serious real-world superpowers. These numbers show exactly why regulators are pushing this transition so hard. The global warming potential, or GWP, drops by a massive 68%. We're plummeting from R410A's staggering GWP of 2088 all the way down to a much more climate-friendly 675. That is a total game changer for lowering the carbon footprint of air conditioning and heat pump systems worldwide. And the eco wins absolutely do not stop there. R32 has zero ozone depletion potential, meaning it's completely safe for the ozone layer. Even more crucially in today's regulatory climate, it is entirely free of PFAS. That means no forever chemicals whatsoever that persist in the environment or accumulate in water and soil. That's a major advantage over some of the blended alternatives on the market right now. Now, what about performance? Well, R32 delivers up to 10% higher energy efficiency and cooling capacity than comparable R410A systems. Because of its superior thermodynamics, systems simply consume less electricity for the exact same output. For your end users, that translates to noticeable savings on utility bills over time. A total win-win. But here is the real kicker. It achieves that boosted performance while requiring up to a 30% reduction in refrigerant charge volume. No way, right? You're getting more capacity and more efficiency while using significantly less chemical volume. This allows manufacturers to design much smaller, more compact heat exchangers and components. Section 3. Understanding A2L mild flammability. We have to address the elephant in the room when it comes to this new efficiency, and that's its safety profile. Let's demystify that ASHRAE A2L classification. The A stands for low toxicity, which is fantastic news. The 2L means it's mildly flammable. Now, I know that sounds a bit intimidating if you're used to the non-flammable A1 rating of R410A, but mildly flammable actually means it is incredibly difficult to ignite. It requires a significant direct ignition source and a very specific concentration of the gas in the air to even catch fire. To put that mild flammability into perspective, its burning velocity is ridiculously slow, specifically just 6.7 centimeters per second. It does not burn explosively like a highly flammable A3 refrigerant like propane. Obviously, precautions are absolutely crucial, but understanding this extremely slow burning velocity really helps put the actual field risk into proper context. Let's wrap up with Section 4, Handling and Installation Protocols. We'll see how this chemistry dictates your absolute rules of engagement for field servicing. Listen to me carefully on this one. Here is a totally non-negotiable rule. Because of the slightly higher operating pressures and, most importantly, the A2L flammability rating, you can never, ever just drop R-32 into an existing R-410A system. R-32 requires systems, compressors, and components that are specifically engineered and certified for its unique profile. It is not a retrofit. When you head to the distributor to pick up these new tanks, you're going to notice a huge visual change. You have to look for the mandatory red-topped cylinders. That red top is an industry-wide visual reminder that you are handling a mildly flammable A2L refrigerant, making sure technicians know exactly what they're working with before a valve is even opened. Let's run through the new servicing rules. First off, you absolutely must use A2L certified spark-free tools. That's your vacuum pumps, recovery machines, leak detectors, the whole shebang. But here is the brilliant part. Because R-32 doesn't fractionate, if you find a leak, you can simply repair it and top off the system. You don't need a costly, time-consuming total evacuation like you do with blended refrigerants. Plus, you can easily charge it in either liquid or gas form. This brings us to a really critical new step in installation planning: calculating minimum floor area based on total refrigerant charge. For a very small charge of 1.224 kilograms, there's no room size restriction. But bump that up to 2.0 kilograms for a ceiling-mounted unit, and the room must be at least 2.55 square meters. This rule ensures that in the event of a catastrophic leak, the R-32 gas cannot reach a hazardous, flammable concentration in a confined space. So the transition away from legacy chemicals isn't just some future concept anymore. It is happening right now. R-32 brings massive efficiency gains, a 68% drop in global warming potential, and vastly simplified top-off servicing. But it also demands a new set of rules regarding A2L flammability. Considering the specialized tools, the red-top cylinders, and those new floor space calculations we just covered, what steps are you taking today to prepare your team for the R-32 standard?